We need to find the interval of convergence for the following series. Series of n to the power n times x to the power n, with n that goes from 1 to infinity. So to find the interval of convergence, we start by applying either ratio test or root test. The ratio test is more common. However, as I look at the series, at this power series, I notice that both factors are raised to the nth powers. So then that means that the root test would be ideal here. So according to the root test, I have to find the limit as n approaches infinity of the nth root of the absolute value of the general term, like that. So let's set up this limit. Limit as n approaches infinity, nth root of, and then absolute value of my general term is absolute value of n to the power n times x to the power n. Now, of course, this can be simplified. I can apply nth root to the absolute value of n to the power n, and I will apply the nth root to the absolute value of x to the power n. And within each, the nth root will cancel the nth power. Now, what happens with the absolute value? Can we drop it? Well, not for both of them. We can drop it for n, because we know that n is always positive, right? That n goes from 1 to infinity. That means that we can drop absolute value for n. However, I won't be able to drop absolute value of x, because x, they can take upon different values, positive and negative, so I will have to keep absolute value of x. So let's look at this limit. What can we say about it? So as n approaches infinity, what can we say about this expression? By the way, keep in mind that since our limit is only given with respect to n, we treat x as a constant. So we can see that this limit equals infinity for all values of x except one value. So for all x except, what value is this? Well, what happens when x equals 0? When x equals 0, we get infinity times 0, and that is an undefined operation. So we'll say infinity for all x except x equals 0, when result is undefined. And we're going to come back to this in a second, but let's first try to interpret this result. According to the root test, what conclusion do we make when this limit equals infinity? Well, according to the root test, the series is divergent when limit equals infinity, right? So that means that for all values of x, well, except 0, this series is divergent, right? Well, the question was to find the interval of convergence, and we haven't found anything yet. In fact, we found that for all values of x except 0, it's divergent. But now let's see what happens at x equals 0. Let's try to plug that into the series. So let x be equal to 0. And by the way, 0 is a special number for this power series. Remember that the power series has the following general form. It goes from 0 to infinity, c sub n of x minus a to the power n. So in the general form, we have a number right next to x. And that number, what we call the center. Well, we don't have a number here next to x because that number is 0. So that means that what we're going to check right now, well, we're checking what happens at the value of x that we call the center. So if x equals 0, you probably can guess what everything is going to turn into. So n to the power n times 0 to the power n. Well, 0 to the power n is 0, and then 0 times anything is 0. So it means that in this case, we get this trivial case, a series that has constant terms, and they're all zeros. And if I add infinitely many zeros, what will I get? Well, I'll still get 0. So that means that, well, the series is considered to be convergent. So converges. And that means that the only value of x where that original power series is going to converge is at its center, which is x equals 0. So we'll say the series converges when x equals 0, and that's the center, so it converges only at the center. And the interval consists of only one point. So if it's only one point, then what's the radius of that interval? Well, then the radius is 0. So r, the radius of that interval is 0. R equals 0. And that's how the answer is going to look like in this case.